This is a magnetic amplifier I built a couple years ago. I've forgotten some of the details, but it uses 3 transformers as the actual magnetic amp. They're all the same style transformer. It's got a separate transformer, and this takes in 120 VAC, converts it to DC, and outputs that into this capacitance. And this capacitance holds the DC power that saturates the windings of the magnetic amplifier to allow the AC to then conduct out to the lamps. And the DC power is controlled with this pot at a lowest resistance to about 1 turn up. It's a 10-turn pot, but only about 1 turn is needed to actually get an effect. So we'll go ahead and turn this on real quick. What we have over here is a 200 milliamp 14.4 volt lamp and a 100 milliamp 14.4 volt lamp, AC lamps. So just power this on. It's all the way on. So you can control that here with this. Alright, you get the dimmable effect. So you can see why it's a interesting way to go about using just switching to control the actual dimming versus having a controlled but reduced amplitude of the existing signal. So semiconductors just use an on-off duty differential to be able to adjust for a dimmable feature at a certain rate without producing flashing to our senses. Anyway, this is a mag amp. That's what it is, and that's how it works for the most part. And there you go. I've actually built 3 times 1000 watt transformers with a 50 VA transformer for the control current to run a 500 watt incandescent lamp load, and it works exactly the same as this. Exact same principles. Everything works the same. Pot, adjust the DC control power, shuts off the lamps or dims the lamps. Same deal. It's just bigger, a lot bigger and a lot heavier, which is why semiconductors and controlling the switching cycle seems to make a lot more sense. But then you have no magnetic field to interact with for the most part. So, trade-offs.